All right, so this is objective 4.2, solving systems by substitution. We are substituting something for something else, something that are equal to each other, okay? So it is all about substitution. It's a very difficult method, but we have to learn how to do it. And then we'll also learn by elimination, and you can choose which one is your favorite and just work with your best method that you can solve. But this one is all about substitution. Okay, so solve the system using substitution. Step number 1 here, you can't see, but it says step number 1. Oh my gosh, I didn't realize that this could not be seen in a PowerPoint. But this very first step right here says solve an equation for one variable. That's what it says here. And then it says step number 2, substitute. And then it says step number 3, solve the equation. It's hard to see. I thought the colors would show well on the video, but obviously it doesn't. So the first thing I need to do is solve the equation for one variable. Two things are given to me, equation number 1 and equation number 2. The first step I should do is solve one of them and get one variable isolated. When I look at number 2, I already see that one variable, which is the variable y, is already isolated. So I really don't have to do step number 1. It's already done for me. This is saying that y equals 3 plus x. So y is, the sign equal can be used as the word is, okay, is. So y is 3 plus x. So I can either use the y, or I can use 3 plus x in the place of y, because they are equal each other, okay? So it's kind of like 50 cents or 2 quarters. I can either have 50 cents or I can have 2 quarters. They mean exactly the same thing. I can use either one. So this is exactly what we have here. It says substitute what this value is for y in the other equation. So I am gonna, it says to step number 1, to solve an equation for one variable. I already have it. I'm gonna use y equals 3 plus x. So in the place of y, whenever I see a y, I'm gonna replace with 3 plus x, okay? So substitute that value of y into equation number, to the other equation, okay? So I'm gonna get x, instead of plus y, plus, instead of a y, I'm going to write the substitution of y, which is 3 plus x equals 5. Okay? So in the place of where y was, I substituted for for the value of y. Y is 3 plus x. And then I just solve the equation for x, for the x value. Okay? I have 1x plus 3 plus another x. So I learned before that I can combine like terms. We have 2x plus 3 equals 5. And I don't know if red shows better than black. Let's try. Let's subtract 3 and subtract 3 here as well. And once I subtract 3 from both sides, I get 2x equals 2, because 5 minus 3 is 2. Now I divide by 2 on both sides, and we get that x equals 1. So I got that x equals 1. Now that I know that x equals 1, I can come back right here at this very first equation, go back all the way over here, and let's solve it for y. So y is 3 plus x, but x equals 1. So this is going to be y equals 3 plus 1, which is 4. So now I know that y equals 4. Remember when we were graphing the two lines? We gave the answer as an order pair. Well, we need to give the answer as an order pair. So the solution for this, is x equals 1 and y equals 4. Okay, that's how you show the solution for this. All right? So, as you can see, you pick the variable that is isolated, replace the value of that variable, variable y, replace what that variable is in the other equation that you didn't use, and then solve it. Your goal is to write one equation with the same variables. Okay, so we replace y with 3 plus x because you want an equation with just x's or just y's. Okay, it's a little bit confusing, substitution. You're putting one equation inside of the other, but we got to keep practicing. Let's try another example. It says right here, which answer checks correctly. So which answer matches for these two systems over here? Okay, for this two equations, a system of two equations. I have equation number 1 and I have equation number 2. Step number 1 is to pick an equation and isolate for one variable. If I look at both of them, I already see that this equation number 2 is isolated for x. X is by itself. Then I'm going to use it. X is, right, x is the same as 4y minus 17. So in the place of an x, I am going to use 4y minus 17, because that's what x is, okay? X is 4y minus 17. Then I'm going to come in equation number 1, which is my step 2. Step 2, I'm going to pick equation number 1, and in the place of an x, instead of the x, I'm going to write 4y minus 17. So 3 times, I'm going to open a parenthesis, because instead of the x, I'm going to write 4y minus 17. Minus the y that was already there equals 4. So as you can see, I grabbed the equation number 1 that had x's and y's, and I rewrote it with just y's. Now it's an equation with just y's, and we know how to solve an equation with just one variable. Let's go ahead and distribute here. 3 times 4 is 12y. 3 times 17, negative 17 should be negative 51. 3 times 7 is 21, and 30, that's 51. Minus y equals 4, okay? So let's go ahead and combine like terms. I have 12y minus 1 of the y's, okay? 12y minus 1y. If I had 12 and I subtract 1, that means now I have 11y's minus 51 equals 4. Now I need to get the y by itself. So I'm going to add 51 here, add 51 here. A negative 51 with a positive 51 is 0. Now I only have 11 y's on this side. But here we have 4 plus 51, which is 55. If you divide both sides by 11, we get that y equals 5. There we go. I know that y equals 5. That is the only answer where it says the y equals 5. That made my solution already. I don't even need to solve for x. Y equals 5 is the only one that matches here. But if I want to solve for x, all I have to do is go back over here and plug in for y. Okay, y equals 5 in place of 4 over here. So x is 4 times, instead of a y, I'm going to write a 5 and subtract 17. Okay, so that would be 4 times 5 is 20, minus 17, I'm sorry, minus 17, it's equals 3. 20 minus 17 equals 3. There we go. 3, 5, 3 for x, 5 for y. This is the solution. Okay, so this is a very similar question that you see on the test, where they give you the order pairs for you to choose from. Okay, and that's by substitution. Substitute one variable inside of the other. Okay, let's do one more time. Let me see if I have another example here. Solve the system using substitution. One more time. Okay, it says solve an equation for one variable. The previous two examples, they already gave us a variable isolated. This one, they didn't. Here's equation number 1, the top one, and equation number 2. Okay, so yep, they're not, none of these two equations are isolated. So I'm going to pick, it looks like the top one is really easy. If I subtract 3y to the other side, I'll get x all by itself. So why don't we do that? Why don't we grab the equation number 1 and we subtract 3y on both sides. So x equals negative 3y plus a 7. So there we go. I got my variable isolated. Now I'm going to use x equals negative 3y plus 7. In other words, x is the same as negative 3y plus 7. I'm going to use this value right here in the place of x, okay, in the other equation. Now step number 2 says substitute it in the other equation. So I'm going to use equation number 2. I'm going to write 4 times an x, but x is negative 3y plus 7. Now let me continue. Minus 2y equals 0. My goal here is to solve for one variable. This is kind of difficult because I have all the variables on one side. Okay, I have the y's and the x's all on one side. So let's see what we get here. 4 times negative 3 is negative 12y. 4 times positive 7 is positive 28. Minus 2y equals 0. I need to find out what y equals. So I'm going to combine like terms. Negative 12y minus 2y, that's negative 14y plus 28 equals 0. I think I have space on the other page over here. Solve the equation. Is this the same example? 3y. Yep. So I have space over here to continue. Solve the equation. Let me continue solving it right here. So I have negative 14y plus 28 equals 0. I'm trying to solve for y, okay? So continue over here. We get, I can subtract 28 to the other side. Let me see if black makes more sense here. Subtract 28, and we get negative 14y equals negative 28. When you divide both sides by negative 14 on both sides, you get that y equals 2, a positive 2, because a negative divided by a negative is positive. 28 divided by 14 is just 2. So we got that y equals 2. Now that I know that y equals 2, plug it in to find the other variable. Okay? Go back to your equation. Used to be 3y plus x equals 7. But remember, we isolated and we got x equals negative 3y plus 7. Now that I know that y equals 2, I just need to plug it back in here. Okay? So negative 3 times 2 plus 7. So x equals negative 3 times 2 is negative 6 plus 7. A negative 6 plus 7 means that x equals 1. Okay? So now I have y equals 2 and x equals 1. The order pair will be the solution. The solution will be 1 for x and 2 for y. Okay? So it was a lot of work. I started on this page over here. Okay, I broke it down in 2 pages. I picked equation number 1. I isolated for one variable because that's the step number 1. Then I plugged it in the other equation and I solved it for y. Once I figured out what y was, I went back to equation number 1 and I solved it for x. And then I found my order pair. X is 1, y is 2. Okay? There's a lot of work. You just have to carefully do one at a time. So here we have another example. In this case, when you look at both of them, I have equation number 1 on the top and equation number 2 on the bottom. Look for one of the equations where the variable is already isolated. You can see the number 1, x is already alone, isolated, so that's great. I'm going to use that one right there. So x is 3 minus y, okay? That's what I'm going to use in the place of an x. That's what x is. X equals 3 minus y. So on equation number 2, I'm going to pick equation number 2. In the place of x, I'm going to write 3 minus y. So instead of x, I'm going to write 3 minus y. Now I continue with the equation. Plus y equals 7. All right? Now let's solve the equation for y. But it looks like when I add them, I have 3 minus y plus y equals 7. 3 minus y plus y equals 7. Looks like when I add a negative y with a positive y, I get 0 y's. The y's add up to 0. I end up getting 3 equals 7. But that is 3 does not equal 7. That's a false statement. So there is no solution. Okay? What happens when two equations have no solution? Do you remember that? That means that these two lines are parallel, right? When there's no solution, that means that these two lines are parallel. They have different y-intercepts, but there's two lines are parallel. And if you want to try to graph them, you see that these two lines are parallel. Okay? So you could get a solution, but you could also get a no solution, especially when this is the case algebraically, where the statement is false, like x does not equal, 3 does not equal 7, so you know that there's a false statement, and that is how you solve it by substitution. So good luck, work on it, practice a few questions, and then show me the work or come and ask me for help, all right? Good luck.